Okay, so the name of this lesson is the activity series for single replacement chemical reactions. In other words, when we do a single replacement chemical reaction, sometimes they work and sometimes they don't. And it's based on whether or not a material is more active or not compared to the element in the compound. And I'll tell you what that means in the next slide. So basically what happens is when you do a single replacement chemical reaction, you have a free element trying to kick out another element in an existing compound. In order for that to work, the element that's doing the kicking out or the replacing has to be more active or stronger than the element that it's trying to replace. If it's not, then there'll be no reaction. Now, how do we tell what that's going to happen? Well, fortunately, we have this sheet or this chart called the activity series chart that tells us which metals and which nonmetals are more active compared to the other materials. And I'll show you how to use that in a second. So the activity series is basically broken down into two charts, the metal side and the nonmetal side. The activity, the element decreases as you go down the list. In other words, the more active elements or the more strong or reactive elements, you can look at it that way, is towards the top of the list, and the less active ones are towards the bottom of the list. An element will not displace an element above it on the list. So if you are below an element on the list, you cannot displace it, the one above it. In other words, you're not strong enough, you're not active enough. And then the last thing to remember is that only metals will displace metals, and nonmetals will displace other nonmetals in a reaction. Metals can't displace nonmetals and vice versa. So here's the chart, and see how it works here. So at the top of the chart, up here, are our metals, and then we have a separate chart down here for halogens. Now our metals, lithium is the most active. In other words, it is the king of the series. So it will kick out anything below it. Rubidium will kick out anything below it. Potassium kick out anything below it. Potassium cannot kick out lithium. Calcium cannot kick out lithium. So when we do a reaction, we look at the two materials, the one that's trying to displace the metal or a nonmetal, and the metal or nonmetal that's being displaced or would be displaced if the reaction occurs. When we compare the two, whoever's higher on the list, that's who wins the battle. So here's my quick analogy. In the animal kingdom, we have a male lion that has a pride, which a bunch of female lions, and only he mates with those lionesses or the female lions. And along comes another male lion who wants to encroach on his turf and get his harem. So they fight. Now, if the incoming lion is stronger, he kicks out the incumbent lion, basically, and that lion goes away, and the new lion comes in and assumes the role of the male lion in the pride. If he's not strong enough and the male lion who's the incumbent are already there beats him, then nothing changes. The male lion who had the pride is still there and nothing's changed. Remember, when we have a chemical reaction, we have to have a change in the situation before and after in order for a chemical reaction to have occurred. So again, the metals on the top, or the metal on the top of this list here, is going to be the one that's most active. It will kick out anything below it. Metals on the bottom of the list will not kick out anything above it. Same thing with the halogens. Fluorine is the most active, iodine is the least active. So iodine will not kick out fluorine, but fluorine can kick out iodine. So let's see how it works on the next page. Okay, so let's see how this works now. So we're going to look at our list over here. Here's my list, and we're going to consult that list. So the first thing we're going to look at is this single replacement reaction right here, this first one right here. Now we said that in order for this to work, the metal, this is a metal, silver, has to kick out the other metal. In order for that to work, the silver has to be more active than the potassium. So we go over to our list and we find our two elements. Silver's right here, and potassium's right here. Now, potassium is higher on the list than silver, and it's already in the compound. Therefore, it's not going to get kicked out. So there's no reaction, right? So there's no reaction because the silver is not active enough to kick out the potassium. Now let's go to the next one. Next one, we're going to look at replacing zinc into the silver area, where the silver is. All right, so if that works, here's our two elements, zinc and silver. So we have to find them over here. Here's silver, and then here's zinc. And now in order for zinc to displace silver, it has to be higher on the list, and it is. So at the end of the day, we're going to get two new things. We're going to get zinc nitrate. That's NO3 because it's +2 zinc, and then silver metal. And then that's that. Now on the next one, we're going to look at the aluminum as the metal, so let's circle that. Now, what is it going to replace in the H2SO4? Because there are no, quote, metals there, right? We said that hydrogen was always considered to be a non-metal. But in this case, this is an ionic compound. The H2 is going to add, the H is actually the metal-like material in this one. So we're going to actually replacing the H. Now, so if we're at work, we have to have this go here. Now, on the list here, there is no hydrogen. On larger lists, there are hydrogen, and it would be right in about here. So we just have to find hydrogens. Let's say hydrogen's right here, and then aluminum. Aluminum's up here. So aluminum will displace hydrogen, and so at the end of the day, we're going to get aluminum sulfate. And that's this compound here, and then hydrogen gas. All right, so far so good. Now the next one we're going to look at is not with metals, it's two nonmetals that are going to replace each other. So here's my chlorine, right? That's chlorine, and that's not going to replace the potassium, it's going to replace the iodine. So for that to work, the chlorine has to be more active. This has to be more active than the iodine. So we go over to our list of halogens, not the metals, and we find chlorine, there it is, and then we find iodine, and there it is. So the chlorine wants to kick out the iodine, and it can, because it's more active. So at the end of the day, you're going to get KCl plus I2. All right, so now here's where you're going to stop and then try to do the last three on your own. All right, now I'm going to give you a little hint. If there is a reaction here, lithium is going to react with the water and form lithium hydroxide. So it's going to replace one of the hydrogens and form the hydroxide, if it works. So if lithium has to be more active than hydrogen to that work, but you get the hydroxide. All right, so stop the video now. When you come back, I will have the answers. So stop the video now.